Hello, today's video is about stereoisomers and we're gonna be completing 4 tasks. So we're gonna start with the first one and start by drawing an enantiomer. Enantiomers are chiral compounds and are mirror images of one another. They are not superimposable. They are also not the same, but have the same connectivity. And we're gonna show that in this example. This is an example of an enantiomer. Also, they have chiral centers represented here. An enantiomer is also asymmetric. They don't have a line of symmetry. So when you put a line, both sides are not the same. So it indicates that it's an enantiomer and not superimposable. For the second task, we're gonna be drawing 2 diastemers. And we are gonna start by drawing an example and then explain. Bold fluorine, a bold OH, and another pair here, a dashed fluorine, bold OH. This is an example of a diastemer. Diastemers are not mirror images. And some, but not all, the atoms are arranged differently. If all the atoms were arranged differently, that would be an enantiomer. But only some can be arranged differently. They have the same formula and the same connectivity, but some atoms are arranged differently, such as the fluorine here. In this example, it was bold, but here it's dashed, and that we only changed one. If we changed both the fluorine and the OH, that would probably be an enantiomer, and we got 2 chiral centers. For the third task, we're going to be drawing a meso compound. Meso compounds are identical, and they are achiral and superimposable. And chiral compounds have no chiral centers, whereas meso compounds have multiple chiral centers, and that's the difference between chiral compounds and meso compounds. And they have meso compounds have a line of symmetry, so if we put a line through it, they are the same, identical. They are superimposable. For the last task, we have to determine the configuration for this compound, whether it's R or S. And we first start by looking for the chiral center, and as we can see, there's a chiral center right here, and we know that because it's tetrahedral and there's 4 different groups attached to this C right here. So first we have to rank the groups from highest priority to lowest priority. So we got a group right here, we got another right here, got one here, and one here. We got hydrogen, O bonded to a C carbon bonded to another carbon, carbon bonded to an oxygen, another oxygen, and another carbon. So when we rank the highest to lowest priority, number 1 is highest priority. So number 1 would be O2 carbon. That's number 1 because it has a higher molecular weight. And we know H is 4 because it's the least priority. And C with the 2 oxygens and another carbon would be 2. And this would be ranked as the third. So now we can number them. So 1, 2, 3, 4. But we still have to rotate the bonds because the lowest priority has to be at the back and the highest priority has to be facing us. So we're gonna redraw it to show that the O double bond, the bold, and now we're gonna be replacing them. So the highest priority, which is oxygen, is gonna go on the boat towards us. And as we said, the least is in the back, so H, and the methyl group is here. So let's number them again. 1, 2, 3, and 4. And when we move from 1 to trace it, 2 to 3 to 4, and back to 1. And as we can see, this is an S configuration because it's moving counterclockwise in the opposite direction of like clockwise. And this was it. I hope this was helpful.